Today's a continuation of yesterday, 3.2 complex numbers. Okay, so real quick warm-up, and then on the side here, I want you to fill in the numeric values of each of those. Okay, work with your groupies, get a couple minutes through them. So let's start with this one. Okay, can I have your attention up here? There's our work for those. Just breaking them all down to their individual pieces, simplifying the perfect squares. And whenever you have root -1, that is equal to I. And you always put your I right next to your whole number. Any questions? Haven't you got all 6? Okay. Let's move on. So, what does I equal? So everyone like just kind of gave up. Come on, guys. The other way to think about that, is that, which means that piece cancels that piece. So my answer is?
Nice.
It is nice.
Trying to confuse us.
Who?
I thought it was just I times I.
Okay. Can I have your attention back up here? I cubed. I am going to say that is I times I squared. And I know I is root -1. And I know I squared is -1. Therefore, I cubed is negative root -1. Some would even call it negative I. I to the 4th is I squared times I squared. Why? Because 2 plus 2 is 4, just like 1 plus 2 was 3. That means -1 times -1, which is 1. I think that's pretty cool. I to the 5th is I to the 1st times I to the 4th. Boy, we really like I to the 4th, just so you know, because I to the 4th happens, oops, that's supposed to be 1. So my answer is root -1.
Wait.
That's so crazy.
And I to the 6th is just I to the 2nd times I to the, I to the 4th. Properties of exponents, you add the powers if the base is the same. I squared is -1. I to the 4th is 1. Therefore, we have -1. No, that's a square right there. That's a circle. Yeah. I to the 5th is equal to I, yeah. I to the 7th is I to the 3rd times I to the... Thank you. I to the 3rd times I to the 4th. I could, or I could do I to the 3rd times I to the 4th. Just trust me like I actually know how I'm going to teach this. Negative radical negative 1 times 1, which is negative radical negative 1. That's pretty radical.
Wait, so it pretty much just goes in like a pattern.
What are you talking about? It's a pattern.
Like, because it starts out with radical negative 1, and then it's negative 1, and then it goes negative radical negative 1.
Oh, so yeah, like if we look at the top 4, root negative 1, negative 1, negative root negative 1, 1. Then we have root negative 1, negative 1, root negative root negative 1, and 1. And so that means this one would be what? Root negative 1, and this would be? Negative 1, and this would be? It's pretty negative. And number 12? 1. Okay, well if that's the case and you're so amazing at it, let's see if you can do... I think you are amazing. Yeah.
Thank you.
Yeah, you're welcome. Okay, let's see if you could do I to the 24. Oh, hold on, not I equals 24. Man, that was an ultimate fail. Hold on. I to the 24. I to the 24. Ultimate fail there. Okay, on the count of 3, everyone say your answers. 1, 2, 3.
1.
Oh, 1, 2, 3.
Negative 1.
Oh. Can anyone justify their answer? Yes, Riley. Why?
You can do I to the 4th times I to the 6th, which is 1 times negative 1.
Hold on. I to the 4th times I to the 6th, I to the 10th. Yeah.
Oh, right. I knew that.
Scarlett?
Yeah.
Well, I just knew that I to the 4th, I to the 8th, and I to the 12 are multiple of 4. The 24 is multiple of 4, so therefore 1.
Yes. I to, if we go back to our pattern, that was very well explained. I to the 4th, I to the 8th, and I to the 12th all equal 1. And all of those are multiples of 4. You guys back there, don't worry about it. It's just your grade. Don't worry about it. Okay? I'm sorry, are all equal to negative 1. Think. All equal to 1. Did I say negative 1?
Yes.
Oh, I wrote negative 1. Okay. Yes, it's supposed to be positive 1. And so therefore, I to the 24th is 1 as well, because it's a multiple of 4. Okay? So if we go I to the, everyone tell your neighbor another one that would be equal to 1. Whoa. Okay, I to the volunteer? Yes?
I to the 144.
I to the 144th. Man, that didn't fit in my box really well. I got to write it up here. I to the 144th power. That is a multiple of 4. Therefore, it is 1. Okay? Yes? I to the 32nd is a multiple of 4, so that is 1. Yes? I to the 1,600 is a multiple of 4, so that's 1. How about I to the 62nd? Okay, you guys, those of you that are using your calculator, that's like shame on you, dude. Okay? Take, and all you have to do to see if a number is divisible by 4 is see if you can cut it in half evenly twice. The first time you cut it in half is 31. Now you have an odd number, therefore it's not divisible by 4. What is the answer, Kai? Oh, I thought you were raising your hand for the answer. Oh, no, we're on this, man. We'll come back to that. Yes? Why is it negative 1? It is a multiple of 2, but not a multiple of 4. So if it's a multiple of 2, which we also call a even number, and not a multiple of 4, then the answer is negative 1. Okay, so everyone tell your neighbor another one that is negative 1. Now, I'm not going to put the box this time because you guys gave me too big of numbers. Wait until we're done. Then you can ask. All right, volunteer. Yes, Chase? 102. Cut it in half once is 51. Therefore, you can't cut it in half again. Yes, 4 does not go into it. Therefore, it's negative 1. Kai? 126. That is negative 1. Yes? I to the 2002. Very good. Yeah, Evan. I to the 16,382. Now, you guys, the other way to test for 4, rather than cutting out, because that's pretty big, you could just look at the last 2 digits, and if it's divisible by 4, then 4 goes into it. And that is negative. Yes. I to the 2nd. Yes. We already said that. All right. Yes. I to the 14th. All those work. Okay. We're going to move on. So, yes, Kai, question?
What if it was like I to the 1/2?
I to the 1/2? Well, we'll talk about, here, I'll show you it right now, and then I'm not going any further. I to the 1/2 is the same thing, and I'm going to write it on this side so I have room. I to the 1/2 is the square root of I. That's what I to the 1/2 is. Now, we're not going into that today, and I don't want to expand on it anymore, but thank you for the question. We will hit on 1/2 powers later in the year. Okay, here's the tougher one. What is I to the 35th? You guys come up with the answer and your reason for it, please. Okay, time's up. Who knows it? I'm going to use pencil because it could be right or wrong. I should be doing that more often. Yes? Root negative 1. How many agree? How many disagree? How many have no idea? All right. Okay, well, let me say this. What is this one? That's 1. It's divisible by 4, right? Which one comes before 1? Ah. Okay, so you guys use this as your roadmap, right? So say, okay, where's the, like, if I were to say, I to the 65th. I to the 65th. Where is the closest multiple of 4? I to the 64th, which we know is 1. So the one after that is? All right. So we have our 1, and then we have, oops. Did I put the wrong one? Oh, I did put the wrong one. We have our I, which is right here, our I to the 4th, our power of 4, and the next one up is there. Okay? You guys with that?
Yeah.
All right.
If it's below, then
Correct. So one thing you could do when you're dealing with these, since you know it's a pattern, you know the pattern now, right? For some reason, I want to keep writing negative root negative 1. Okay, you know the pattern. First, second, third power, and fourth power. Okay? So if you can always figure out where that 1 is, then you can calculate where the other ones are very fast. Okay? That was the purpose of today. Plus, yesterday on your assignment, your student journal page, some of you encountered some different problems. Now, most of you did fine with these, I would guess. But let's take a look at it. Your extra practice is page 53. Why don't you go ahead and tell your neighbors what you got on this page just to begin with. Well, here are the answers. Just see how you did. Number 1, 7i. 2, 2i. 3, 3i root 5. 4, negative 20i. 566i, and 625i root 3. Any questions on those? Okay. Number 7. We did as a class, but number 7, you get -3. And number 8, -1. So x is -3, 1, excuse me, for 7. And then number 8, x is -176 and y is 14. Okay. Now remember, recall on these, you're just saying real part equal to real part. So 44 equals -1/4 x. And then imaginary piece to imaginary piece. -1/2 yi equals -7i. So setting each part equal to its corresponding number type there. Caitlin. -176. So I get 44 equals -1/4 x, right? And then I got to multiply both sides by -4. Yeah. So multiply both sides by the reciprocal there. Yeah. Other questions there? Okay, moving on. The next page, go ahead and discuss those problems with your neighbor, the top set there at least. Pair them up. Let's check them out here, at least the top part. Numbers 9, 10, 11, 12. Actually, you know what? Better than that, I actually want to show you these. Go through them real quick. I know number 9 we did as a class yesterday. Oh, we did? Okay, well, I thought about doing it as a class yesterday, and it's thought that counts. Okay? And then the other day, like after you guys left, I put on the music, and I actually thought of you guys. Oh. Yeah, I was listening. I was like, oh, 5th period. All right. We had our real parts. We had our imaginary parts. I don't hate you. Okay. Man, Kai, that's not very nice. All right. I did it right, too. Aye, Captain. All right. Good? Yeah? No? Okay, so just combining your real part to real part, imaginary to imaginary. So in this one, I'm subtracting now. Mine usually works better in addition, so I'm going to change that to plus and distribute 36 minus 12, or 24. And then I have -3i and -24i, which gives me -27i. Total yay. How many did it right? Okay. How many made it a lot more complex than they needed to? Well, that's why we try these, right? Now you know what not to do and what to do. Okay, that would mean this one is 16 and -16, which gives me 0. And then I and -8i, which is -7i, which we can simplify to be
Yeah, I got that right, so.
-7i. Now, you guys, we have ignored one question here. It says classify as a real or imaginary. And if it's imaginary, specify if it's a pure imaginary. This is what type of number?
Imaginary.
This is imaginary. Why is this imaginary?
It has an imaginary.
Because it has an imaginary piece. All it needs is one imaginary piece, and that makes it imaginary. Therefore, number 10 is imaginary as well. Now, if it's lacking the real piece and it's just imaginary, that makes it a pure imaginary. It's like when you have pure fruit juice. I can't even say that. Okay?
100%
Yeah. All right, so this one right here, add. For those who are like, what in the world is he doing? Why does he keep doing that? It's like having, hey, first, before you announce to the world, that is like a early algebra 6, 7, whenever you dealt with integers skill. Okay, so we should know that already. That's why I'm doing it like you know it. Okay, you are really distributing -1. And guys, I don't say that stuff to make you like, oh man, I'm horrible. Okay, I'm not doing that. I'm trying to just let you know, like, when I do those things, it's not like something you missed this year. It's something that you're not remembering from previous years. And when you hear that, you need to ask, you need to stop. It's like, hey, I don't get what you just did there and why. And then I could say, well, it's like there's a -1 there and you're distributing that. That's what's happening. Okay? It's flipping all those signs to plus then. Or to negative if they were positive. Okay? So this becomes -5, or is -5, and we're adding to it 6, which gives us 11. And this is -5i and positive 6i, which is I. That is
-5 plus 6 is 1, not 11.
-5 plus 6 is 1. Positive 1, actually. Good thinking. Let's rewrite that right there without the positive sign. I think someone's listening. I want you to know my answer key earlier today. Who was standing up there? Someone stood up there and just like dum-dum after dum-dum after dum-dum. Whenever I was making that key this summer, I must have been really distracted by something because I made like 3 errors in a row. So I almost ran out of dum-dums. Yeah. All right. Number 13. They're multiplying now. I believe that's 135. How many made it that far? Good job. All right, let's keep going. 9 times 15.
Where'd you get the one?
-1, or, yeah, -1 times I.
And then, how do you just get 1? Oh, I get it.
Okay, how many made it that far?
Oh, no.
Okay, well, if you didn't make it that far, let's learn from it. It's just using FOIL, right? We did it last chapter. Okay, we've reviewed it. Same idea. Now, when we're looking at this, though, you now know that I squared actually can be called something else. I squared is what? I squared is actually -1.
So just be plus 9.
Which means this is now, correct? I'm going to run out of room here, but -15 plus 136i. And then I have -9 and -1, which makes +9. You're multiplying them, right? I squared is -1, so -9 times -1 is +9, which actually means this answer is -15 plus 9 is
-4.
-6 plus 136i. Common error, though, the -4 thing.
Oh my gosh.
I think that's the answer. Okay. Now, most of you did not get it, so let's make sure you did 14 correct. Why don't you try number 14? Multiply it out. Okay, let's see how we did. 169 and -13i. And then we'll go this route. +13i and -I squared. And you will notice that this ends up giving you 169 minus I squared. Now, this is the difference of two perfect squares. How many of you recognize that? Okay, if you recognize that, like when you have the exact same thing in here but a plus and a minus, that's just that number squared and that thing squared with a negative in between. Difference of two perfect squares. It's a pattern you want to recognize, but right now we're not going to talk much more about it. This piece right here, this I squared, is actually what? That is -1. And so I have 169 minus -1, which is 170. Whoa, that is a real number. Really cool. Time in. Oh.
Sorry.
Come on, Ethan. We're moving on. You gotta.
I understand. Never mind, I got this.
So just so you're aware, we are going to skip 15.
Is it?
You guys, if you're going to study circuits or electricity, then you probably go into more detail than the couple minutes we'd spend here. If you really want to know about how to do that, it's a very easy problem to do. It's on page 106. We're not going to go through it because it touches on it for a second and then it never hits on it again, and we're not going to deal with that. Okay, number 16. I'm going to just go through these fairly fast. Just subtract 25, negative 25 equals 5x squared. Divide by 5, so x squared equals negative 5. Take the root. X is equal to plus minus root negative 5. And then pull out the negative 1 to get I, so it's plus minus I root 5. Okay, so you tried it. Hopefully you got close or got it. How many got it? How many were like right there? You were so darn close. Okay. I is root negative 5. So root negative 5 is negative 1 times root 5. Yep. Number 17, same thing. Going to add 10. So we get x squared equals negative 8. I'm going to take the root. So that means I'm going to have plus minus root 8, or root negative 8, excuse me. When I pull out that negative sign, it becomes an I root 8. And then I have to simplify root 8 to become 2 root 2. So x equal plus minus 2I root 2. I think that's pretty neato. We got our cool squiggly brackety things. And the last but not least, number 18, and one of the ones I messed up on earlier, at least I had the wrong answer on my key. 4/3 we added over. It's a fraction, right? 4/3, subtract 4/3, or, well, I'm going to do that. Subtract 4/3, that gives me negative 5/3. X squared equals 1/5. Multiply by the reciprocal to get rid of the fraction. What's that? Negative 3 over 5, yes. Okay, and so when I multiply by negative 3 over 5, that ends up giving me negative 3 over 25, which is equal to x squared. I know that looks ugly, however, you should recognize the denominator is a perfect square, which is really nice when you take the square root, so you get x is equal to plus minus root negative 3 over root 25, which is 5. And then we pull the I out of that. It sounds kind of gross when you're saying you're pulling your eyes out. Okay? Yuck. But it is Halloween time. So it doesn't make it right. You can't like go pull things' eyes in. So you get plus minus I root 3 over 5. I love it. I know. Okay, we're going to skip 19 for now so we can actually do some other math. What I want you to do right now is tell your neighbor 2 things that you get really well and 2 things that you don't get really well, and see if they can help you out while I'm passing out your assignment. Okay, any questions that I can help with real quick? Your assignment is practice A 3.2. You got it here. Please note there's a front and the back. Some students, my last class, I think, were really happy until they turned it over. Like, whoa! They started crying a bit. So. Okay, so just so you know, hey, at least I didn't write on the edges.
Has Mr. Google ever done a sad woohoo?
Huh?
Has Mr. Google ever done a sad woohoo?
Maybe. Oh, I've never heard it, though. Yes, it is all of it, and you are welcome. That way you know imaginary numbers. You will not be surprised around Halloween of these numbers floating around. Man.